Okay, so we are now going to do some word problems using permutations and combinations. Again, my formula for my permutation is I'm taking n factorial divided by n minus r factorial. For my combination, I'm going to take n factorial divided by n minus r factorial. But since the group 1, 2, 3 is the same as the group 3, 2, 1, I'm also going to divide that by r factorial to get rid of the repeats. And so if the order is taken into consideration, it's a permutation. If the order is not taken into consideration, it's a combination. So, wants to know, for my permutation, how many ways there are choosing 3 letters from the letters A, B, C, D, 4 choices. So I have 4 objects, I'm going to take 3 of them at a time, and I'm going to figure out my permutation. So 4 factorial over 4 minus 3 factorial, which is 1 factorial. 4, 3, 2, 1 over 1, 12 times 2 gives me 24 different arrangements that I could have. A, B, C would be different than C, B, A. Now, if the order is not taken into consideration, I'm doing a combination of 4 things, taking 3 at a time. So I'm going to have 4 factorial over 4 minus 3 factorial times 3 factorial. So I would have 4 times 3 factorial, since I have the bigger one that I want to use, over 1 factorial. The 3 factorial is going to cancel out, so I'm going to have 4 over 1. I only have 4 possible combinations instead of 24 possible permutations. So if I have A, B, C, D, and I'm taking 3 of them at a time, here A, B, C is different from C, B, A. That's 2 different ways. But here A, B, C is the same thing as C, B, A. It's the same group. That only counts as 1 arrangement. So it narrows down and cuts out the number of possibilities. I have 24 permutations, but I only have 4 combinations that I could make. So, how many ways are there of choosing 2 objects without replacement from 4 objects? A pencil, eraser, desk, and a chair. So if the order is relevant, if pencil, eraser is different from eraser, pencil, then I have 4 objects taken 2 at a time. 4 factorial over 4 minus 2 factorial, which is 2 factorial. So 4 times 3 times 2 factorial over 2 factorial gives me 12 different ways of arranging my 2 objects from those 4 selections. Combination of 4 things taken 2 at a time where my order is not relevant. If I grab the pencil first and then the eraser, it's the same group as having the eraser first and then the pencil. So I'm going to have 4 factorial over 4 minus 2 factorial times 2 factorial. So I'm going to have 4 times 3 times 2 factorial over 2 factorial and 2 factorial. So here that's going to cancel. 2 goes into 4 2 times. 2 times 3 is 6. So I have 12 permutations, but only 6 combinations. And one last one on here. It says how many ways if they are choosing 2 objects without replacement from the 5 objects, pencil, eraser, desk, chair, and lamp, if the order matters. So if the order matters, I'm going to do a permutation of 5 objects taken 2 at a time. 5 factorial over 5 minus 2 factorial, which is 3 factorial. So 5 times 4 times 3 factorial over 3 factorial. 5 times 4 is 20. I have 20 different permutations. Pencil eraser is different from eraser pencil. Pencil desk is different than desk pencil, and so forth. If the order does not matter, 5 objects taken 2 at a time doing a combination, I would have 5 factorial over 5 minus 2 factorial times 2 factorial. So that would be 3 factorial. So 5, 4, 3 factorial, and then 2, 1. That would cancel. 2 goes into 4 2 times. I'm only going to have 10 combinations instead of the 20 permutations. So permutation, the order is important. If I switch the order, it's a different permutation. Combination, the order doesn't matter. If I switch the order, it's still the same grouping, still the same group, the same combination.